And so integration formulas for inverse trig functions can be disguised in many ways. Completing the square helps when quadratic functions are involved in the integrand. So we can rewrite those as a something squared. For example, the quadratic x squared plus bx plus c can be rewritten as the difference of two squares by adding and subtracting b divided by 2 squared. Right? So if you have something, you have a quadratic function here, because you need it to be, it's kind of like the equation of a circle, right, where you need it to be a something squared and a something squared. We can make it be a something squared by completing the square, and then we'll have a something squared, and then we'll have this constant term.
I know how to complete the square, but I don't know what any of this says.
Just remind you of completing the square.
Oh,
Right, because when you complete the square, you add b divided by 2 squared is what make it a perfect square. And there should be an example. So here's an example, right? Right, so doesn't look like anything, right? And it's stuck in the denominator of all things. And the substitution isn't going to work here because I don't see a 2x minus 4 someplace. If this had a 2x minus 4 up here, well, then we'd just be doing a u to u substitution, right? And it would have just been a natural log. But it's not. So try to do something. And if you've got quadratic in the denominator, try to rewrite it using completing the square. So quadratic in the denominator. I know. As I forgot what letters I've written. It's so slow.
You've written the.
Quadratic in denominator.
Did you not write the?
Oops.
Nobody needs the.
We don't need that. Rewrite using completing. It's like writing in invisible ink, the square.
If I do my homework in invisible ink, can I get credit?
No.
You have to get black
The
light.
question was, can Russell get credit for writing his homework in invisible ink? And the answer is no.
Maybe. There you go.
All right, so this would be x squared minus 4x. And then what do I want to add to make that a perfect square? 4. All right, so now I just can't go willy-nilly adding things. So if I add a 4 here, I have to add.
No, that doesn't make sense.
Usually you do completing on the square on an equal sign.
Yeah,
so you move the constant over to the other side.
What?
Oh, negative.
There you go.
Correct. 3.
I haven't truly changed it, right? I added a 4 and I subtracted a 4. So I haven't changed the values. I've changed the format because now I have an x minus 2 squared plus a 3. So we've almost got a something squared, right? Because I can just rewrite that as x minus 2 squared plus the square root of 3 squared.
D morph to an A over time.
It's better than A morphing to a D, right, Russell? All right, so now which one of our, now we do have an inverse trig function. Who's it going to be?
Arctan.
Arctan. All right, so now our integral is going to be, all right, so what should I write first?
1 over a, so 1 over x minus 2. No, is that not right? Yeah, that is right.
What are you talking about?
That's not you. I thought it was.
Oh,
I thought it's 1 over a.
that is A.
1 over a is x minus 2, isn't it?
No.
A's got to be the constant.
Yeah.
I could switch the ordering here.
Oh yeah. Okay. I see. A is the constant.
So if you don't like the order because it doesn't look just like it, they're just added, right? So we'll just switch the order. So the square root of 3 squared is first, and the x minus 2 squared is second. Okay? But this is the a and this is the u, right? It's the fractions made with the constant. All right. So now what was it again?
1 over square root of 3 x minus 2 divided by 3 root of 3 plus c.
Perfect. That's exactly it.
Every single time. Russell, where were you at?
What are you talking
Plus
about?
c.
Plus
Thank
C.
you, Riley.
Okay.
It's
So
almost-
they're a little bit tricky, but you get start to get the hang of them after a while.
Juan, what's your grade in calculus?
Huh?
What's your grade in calculus?
B.
Oh,
No, I'm just kidding.
is it C?
Yeah.
Okay, so plus your grade in calculus.
What's your grade?
Let's see. See, I won't forget either.
Really?
That's
Oh, why didn't you
Hashtag
see?
85.
What is
We all have C's. Woo!
What a I already said.
I don't.
Barely a C.
What is it?
70.
A 70? Oh my god.
Remember, you can make corrections.
And turn in
And
your
they will
work.
be, at the end of your work, Russell, and they will be accepted throughout this semester.
Will be accepted during the summer.
No.
You
said the semester, not the summer.
So if your leading coefficient is not 1, you'll have to factor that out before completing the square, and you hope that it doesn't give you a bunch of fractions to work with. So if we had 2x squared minus 8x plus 10, we'd have to factor out the 2 first and do completing the square with that. But we have to remember, though, that if I add, if I add a 2, add a 4 here, it's technically an 8. And I don't know why it says oh, that's the plus 5 from before. Actually, they messed up on my example one here.
How?
Fire them.
No, it looks right. They did it right.
Oh, no, that's right. They just factored out. That's right. I'm sorry.
Don't
It's not an
fire
equation.
them.
I got to think about it.
Don't fire them.
Don't fire them. So actually, when it's an equation, you would add twice as much. But the 2 isn't going to matter here so long as
It's only when you're adding it outside of the
Yeah.
equation.
All right, so, and the same thing, if it's negative, same thing, factor out the negative first, because x squared for completing the square has to have a coefficient of 1, nothing else, okay? So anything else, you'll have to factor it out. So, an example, oops, don't we have an
I
example?
like that example.
That's a great example.
I know, that's a great example.
Makes me have 1 over in
Oh, no great
Inspirational.
examples. We'll get an
Something hidden in
example.
this slide.
All right, so I'm gonna stop the tape so you're not just standing here, those who are watching a podcast. I'm gonna go write a problem down, and then I'll be right back.